I've been a figure skater for the past 13 years, and my favorite skill has always been spins. But I've always wondered, how do I go faster? The answer lies in physics, specifically angular momentum. First, let's review linear momentum so we better understand the rotational version. Linear momentum is represented by P, and it equals the mass times the velocity. Now, in rotation, it's called angular momentum, and that is represented by the variable L, and that equals the moment of inertia, or I, times omega, or the rotational velocity. I, or the moment of inertia, is equal to your mass times your radius squared, where your radius is the distance from your center of rotation. And omega is equal to your radius divided by your mass.
Huh?
Okay, let me give you a real-life example. Imagine a figure skater about to enter a spin. The center of rotation is represented by this blue dot, and when their arms are fully extended, they have a really big R. But when they pull their arms in, they have a really small R. This ultimately changes the moment of inertia, which is important to understand for how a spin goes faster. But first,
I get it.
First, let me explain the physics principles of how a skater actually enters a spin. Newton's first law states that an object in motion will stay in motion unless acted on by an external force. When you start a spin, you need a force. In rotation, this force is called torque. A skater generates torque by using the edges on the blade when they enter a spin. When spinning, there are very few external torques being applied, and because of the conservation of momentum, which is basically stated through Newton's first law, the angular momentum must be constant. Moment of inertia is key when understanding how to spin faster. Physics is all about balance, so since angular momentum must stay constant because no other external torques are being applied, if you decrease your I with a smaller r by bringing your arms in, then you must have to increase your angular velocity to compensate. This is exactly how skaters increase their speed when spinning. This is also how they finish their spin. If they want to decrease their velocity when going out, then they must increase their R by extending their arms outward and making their R bigger.
Here you can see in this scratch spin that I decrease my moment of inertia by bringing my arms in, therefore I spin faster. The same principle applies to jumps. A great example is this double toe loop. When entering the jump, you use your toe pick and edge to apply a torque against the ice. Once I'm in the air, I'm in projectile motion, which means I'm in a parabolic path and no more torque can be applied. This means my angular momentum is now constant.
Hope you had fun learning about angular momentum. Go to your nearest ice rink and try this principle out for yourself.